Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by confirming Fakepixel version and saving configs. This prevents regressions. Once done, enable developer mode and open the protocol debug log so you can observe the failing handshake in real time. You need to identify whether the failure is a timeout, checksum mismatch, or unknown opcode because each has a different root cause. Make sure to capture a 1-2 minute trace and note packet ID and timestamps. That data is what you'll use for targeted corrections in the next steps. You now recreate the failing session with packet captures filtered by session ID and protocol port so you can reproduce the exact error conditions. Then you compare live packets against the Fakepixel protocol spec to find mismatched fields, wrong encodings, or unexpected padding. This explains why the peer rejects messages. Next, edit the protocol handler. Correct serialization routines, adjust byte order where needed, and add or validate checksums so messages meet the spec. You finish by deploying the patched handler to a staging environment and running integration tests across 10 or more sessions to catch edge cases. Once done, monitor metrics like error rate, handshake latency, and packet loss percentage to ensure stability. If problems persist, enable verbose logging and perform a commit bisect to isolate the offending change. This reveals regressions quickly. Make sure to roll back if new errors surface, and keep a minimal reproducible trace so you can iterate without impacting production.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.